Alright, we are back, and let's jump back into this program and see why our simulation just is not doing what it's supposed to be doing. So what's going on in here? Let's see. We can see that we're running update, and we can see that we're getting our refresh trigger. Let's check. I'm actually not seeing the refresh trigger. Okay, I just saw a couple of flickers, so we can't see it every time, but it is refreshing. And when it does refresh, we should be updating our values. And every time we update our values, we're loading our temperature, which is fine because we're storing our temperature at the end. And our temperature is 0, so we're storing 0 into our local temperature. Then we're pulling our level, and we're storing that into our local level. And our level is currently 50, apparently. Yeah, well, no, our level is actually 0.3, and then somehow we're storing that into our local level, and I think I see the problem here. We're calling it A, and then we're actually using B. What's going on is we're calling the temperature and the level to look at those, but then we should be managing something a little bit different. So we should actually be controlling the input signal. And I think we're just adding these to the actual values themselves. So let's jump out of there, go offline, and we've got a little bit of rework to do in this program. So let's jump in. We're pulling the temp and calling that local temp. We're pulling the level, calling that local level. That's great, but we also need to be pulling something else. So let's go ahead and pull, and we're going to look for TE, and let's see if we've got temp in. There we go. We want to pull local temp and call that local temp in, and we will define that as a real. Got that. And then we also want to, we're pulling local level, but we also want to pull level in. So let's go ahead and copy, let's go ahead and copy both of those. And we're going to pull, I believe that's LVL underscore in. There we go. And we're going to store that as local level in. Alright, so then we can save that as a real. And once we've got those, we don't need to load temperature again. Now we can just load local temp, compare it, and from then we're not working with local temp, we're working with local temp in. Alright, and coming down here, same thing. We are not looking at local temp, but we're adding to local temp in. Then according to our pump, we're doing one of a couple of different things. And again, we're going to be changing temp in. And when we come down here to local level, we're going to be doing the exact same thing. We're going to be modifying our input signal, not actually our scaled value. And then we're going to come down here and write those out. Okay. I bet that will work a little bit better. Let's give it a shot. So let's come back here into globals and fire a true on that. And we've still got our values retained for our drain and fills. So now we can actually see, good, we're getting some steady change on both of our levels. So good. And let's see what our temperatures look like. Those, I know they've got to be somewhere in the list. Here we go. Our temp in. And our temp in is actually dropping. That's not good. And our temperature is still equal to 0, of course. So we know our temp in isn't, either the logic isn't working, or, well, no, we know the logic is not working on our temp in, period. So our level is coming in, and that's working pretty well. And let's see, that's getting up 22, 23. Alright, that's pretty good. We could probably modify our fill rates if we wanted to, and we could make that happen a little bit faster. So maybe I'll take that fill rate up to, let's say, maybe 100, and then I'll take the drain rate down to 40. So maybe we'll just double our fill and drain rates. And let's see, we've got our level up to 38 and still climbing. And I'm not going to wait for it to go all the way because that's going to take a little bit too long. But I do definitely want to see what's going on with our temperature, because our temperature, especially our temp in, it just keeps getting lower and lower, and that shouldn't be happening. So let's go back into that simulation logic once again. And actually, before I get too carried away in here, let's go back to those global variables. And I want to set that drain rate a little bit differently. So we're going to go ahead and double both of those. That should be a little bit more immediate of a response. And while we're at it, let's just go ahead and risk it a little bit and double our temperature change rates as well. So let's jump back in and figure out why on earth is our temperature going the wrong direction. So let's jump back up in here in the top and let's see. Okay, we are calling in our temperature and we are setting everything right here. So we've got our local temp and we've got our local temp in. If our local temp, not temp in, but the temperature is greater than 70, then we can go ahead and check for dropping temp. Otherwise, we can go for heater check. So if our temperature is greater than 70, then we can drop heat. But otherwise, we can't drop heat here. And this is also where we need to check for our pump dropping. So instead of checking down here, we need to go ahead and pull that up. So let's go ahead and copy this. Actually, rather, let's go ahead and cut that out. Come up to drop temp. We've got our natural temperature drop, and then we've also got our pump is running temperature drop. So this is our natural temperature drop without the pump pushing in a bunch of, fresh whatever it is. And we're skipping past that because we know that we're not greater than 70. So that means that we're going to jump to heater check. And if our heater is energized, then we should be raising the heat. Now if we raise the heat, we're taking our local temp in, we're adding our heat up, and we're storing that. So we should be moving up. However, I think our pump is causing us to drop heat. And let's see what happens. When we come to pump, that's saying if the pump is running, then reduce heat. So maybe our heater is just not raising the heat as fast as what we're reducing it. And here we go. That looks like that's true because we're dropping heat a lot faster than what our actual heater is actually allowing. So we should actually be multiplying that by a fraction of what the heater can actually generate. So instead of that being 3, I'm going to change that to 0.3. And then we're going to subtract that out. So now if the heater's running at the same time that the pump is running, we should be heating a lot more than what the pump is drawing us down. And I'm actually going to change that to about a 0.15. So I think that's going to do it. And again, we only really want that to happen if we're above 70 degrees. So I'm going to come back up here and let's go ahead and copy this logic out right about here. And let's come back down to that raise heat right here. And let's paste this logic in. So if local temp is greater than 70, then we're going to jump to, and I'll just call this drop to temp. And then I'll create another JMP right there. And then our drop to temp will be right here. And that's what's going to bring that down. Otherwise, we're going to jump to level check. And there we go. All right, I think that's going to have our temperatures doing what we want them to do and our level as well. So let's come back into our global variables and put this system online. And after 5 seconds, our heater and pump should come on. And there we go. Now we can see our level raising. We can also see our temperature raising. Good. Now let's just watch for a second and make sure that they don't go too high. We don't want them going crazy. So our level is still pretty low, temperature's still pretty low, but that's okay. We know these things take time and they're actually moving pretty good speed. And I'm happy with that for simulation values. Technically, especially on startup, it would be nice to see these things going a little bit faster. But once you're actually in process, if they're going too much faster, you really can't run back and forth and see what's happening. So I'd rather kind of have them a little bit slow, at least for a little bit. But we're about up into operating range now. So we've got our temperature coming up, our level. I think those are about in the range that we want them. Now that our temperature's above 300, we can see that our mixer is running. And once our mixer's been running for 30 seconds, we should be able to see our mode go into mode 3. So keep an eye on that mode, and let's see if that goes into mode 3 once it's been running for a little bit. But other than that, let's just check and make sure our temperatures don't go crazy. And we can see our temperature is going up and down a little bit, so it's actually working to control that. And how's our tank level? Our level is at 74, and now it's dropping. And now it's coming back up. So, okay, it looks like some things are happening in our system. We can see our pump going on, coming off. We can see our valve opening and closing. But I also see those things happening a little bit too quickly. It doesn't look like we're getting our delay in there. And our mixer's shutting off, so right now I would say our system's a little bit out of control because it looks like we are not actually getting our delays. And other than that, our temperature is definitely lower than we want. So we want our temperature to be going up around 300, and now we can see it falling down. And our level is staying up, it's around 80, and then it's coming back down, I guess. So yeah, we've got a little bit out of control, but the good news is I think our simulation routine is good. Now we've just got to manage our process control a little bit. So let's go ahead and break here, and we're going to call simulation good. And when we come back, we're going to start looking at our process control actually in the step that we're on, in step 2, and seeing what's going on there. So until then, take a break, and we'll come back and jump back in.